Now let us take a look at ionic bonds and covalent bond. So what is ionic bonds? So you already know that ionic bond is formed between a cation and an anion. So of course, there are few factors that influence the magnitude of the ionic bond. So the first factor is the lattice energy and the second factor is the ion size. Okay, if we look at the lattice energy means energy that is required to separate completely a mole of solid ionic compound into its gaseous ions. For example, you have a sodium chloride here, and then you want to break this sodium chloride into its gaseous form. So you have sodium plus and chloride ion in gaseous state. So the energy that are required to break this molecule is plus 788 kilojoule per mole. So in this case, plus 788 kilojoule per mole is absorbed when 1 mole of sodium chloride is separated into the gas phase of sodium plus and chloride minus. And this energy depends on charges of the ions and their size, meaning if the ion has stronger charge, so the lattice energy is higher, but if the ion has smaller size, the lattice energy is also higher. So in this case, stronger charge of an ion and the smaller charge of the ions will result in the higher lattice energy. Okay, so this is the formula how we can calculate the lattice energy. So this EEL here is defined as potential energy of two interacting charged particles. So it is equivalent to the constant K here, and then Q1 times Q2 divided by D. So Q1 and Q2 is the charge of the particles, and D refer to the distance between their center. So if you look at the definition of the lattice energy before, it says that the higher charge of the particle, so the higher charges of the ions or particle, so it will increase the potential energy here, and the distance here refer to the size of the ion. So the distance between their center, the smaller distance between their center will increase the potential energy at this site. Okay, for example, if you arrange the following ionic compounds in the order of increasing lattice energy, so in this case, cesium iodide will be the lowest in lattice energy because cesium is plus 1, but the size is big. And if you look at sodium fluoride, so sodium has plus charge, but it is smaller than Cs. That's why it has more lattice energy compared to the cesium iodide. And if you look at the strongest one, I mean the largest, the one with the largest lattice energy, the calcium here has 2 plus charge. So that's why it has higher lattice energy compared to sodium fluoride and cesium iodide. Okay, now let's us discuss on the covalent bond. So when a bond occurs in between two atoms by sharing their electron in order to obtain octet condition at their orbital valence, so this bond is what we call as covalent bond. And sharing a pair of electrons can be denoted as A dash B, which can be named as single bond because there is only one bond here. So this is the single bond. Double bond and triple bond consist of 2 and 3 shared pair of electrons respectively, and while lone pair electron is referring to those electrons which are not involved in the sharing. So that is lone pair electron. Okay, so in covalent bond, there are also two subcategories. The first one is the non-polar covalent bond, and the other one is polar covalent bond. For non-polar covalent bond, electrons are shared equally because the atoms are of same electronegativity. For example, if we have nitrogen atom here and it shared electron with another nitrogen atom, so what will happen is that you will see there are two shared electrons in the middle and there are two unpaired electrons each. So in this case, to achieve octet, so both of the nitrogen need to form a triple bond like this. So this is what we call as non-polar covalent because both of the atom has the same electronegativity. While for polar covalent, one atom has greater attraction compared to the other atom because they have different electronegativity value. An electron will be closer to the more electronegative atom. Okay, for example, HCl. So HCl here, in this case, Cl is more electronegative compared to the hydrogen. So this hydrogen is known as partially positive and chlorine here is partially negative because it is more electronegative compared to the hydrogen. Okay, if we look at the polarity, the electronegativity difference and how it can influence the type of bonds for fluorine compound. Okay, if you look at the table here, the first one is the fluorine gas, which is F2. So this is using the same atom. Okay, the electronegativity difference is 4 minus 4, so it is equals to 0. So type of bond is non-polar covalent. Okay, let's take a look at another example, which is HF, hydrogen fluoride. So hydrogen fluoride is 4 and hydrogen electronegativity is 2.1. So the difference is 1.9. 1.9. So it is a polar covalent compound. Okay, next we take a look at lithium fluoride where the difference is 4 minus 1, so it is 3. So when it is more than 2, it is considered as ionic bond. Okay, look at the general rule here. So how do we predict type of bonding depend to these three general rules. So the first rule is if the electronegativity are equal, so or the electronegativity difference is 0, the bond is non-polar covalent. Okay, the second rule, if the electronegativity differences between the two atoms is in between 0.1 to 1.9, so the bond is polar covalent. But if the electronegativity difference between two atoms is 2 or greater, the bond is considered as ionic bonds.